So I'm going to take you straight to the panel. I think it's an amazing panel, and I let everybody introduce themselves and tell you a little bit about their journey. But those are the people who grew the industry and progressed the data science as a profession a lot. I would say despite the hype, and that's a pretty honorable thing to do. So please welcome our panelists with a small round of applause. Can you just maybe let's start with Magnus and a few words about yourself and where are you and how did you get there?
Okay, so I'm a director of a data science institute actually, and maybe managers of data science teams, directors of data science institutes are sometimes not data scientists, but I think I am. So I've got sort of background in machine learning and computer science, but I've moved closer to the data. So now I work in sort of genomic data, big biological data, and I still develop sort of machine learning methods, but I'm becoming more applied, and I work a bit with companies as well.
Should we just go along? Yeah. So hi everyone. I'm Piers Stobbs, and I have been Chief Data Officer at Money Supermarket for nearly 4 years now. And Chief Data Officer doesn't sound like data science, but I like to think I am. I'm in the slightly fortunate position of actually being reporting into the CEO. It means that we have a certain amount of, power, but also kind of leading the broader data teams in the business. So not only data science, but also analytics and data engineering, which I think it means that we can do things that perhaps it's easier to do things that perhaps other companies can't. But yeah, so my background, a long time ago I did physics. I was an oil engineer for a while. A fairly eclectic career. I was in the States in various startups, all sorts of industries. Spent about 5 years as a quant, building all sorts of nice quantitative models, learning all sorts of fun machine learning techniques. And then I guess most recently ran data science and advanced analytics at Dunnhumby, which is Tesco Clubcard, so lots of consumer grocery data. So a bit of everything.
Hi, I'm Kate Land. I'm the Chief Data Scientist at Havelock London. It's a new investment management business that I co-founded. And the great thing when you co-found a business, you get to make up your own title. So there were 4 founders, and we all just called ourselves Chief something. So I'm the Chief Data Scientist. Before founding Havelock London, I spent some time working in fintech, but before that, I spent 8 years at Winton Capital, which is a quantitative fund. And what we're trying to do with Havelock London is try and bring the best of the kind of what we learned there in terms of taking a very systematic approach and a very disciplined approach to building investment strategies, but we're now applying that to more traditional ways of investing. So there's usually a big gulf in finance between the people who drive things with data and then the people who kind of don't, that sounds really mean, but who kind of, I don't know, read The Economist on the way to work maybe, from The Economist, and pick some stocks. So anyway, we're trying to bring the best of the two worlds together. There's a lot of wisdom from the traditional way, and there's a lot of great expertise in the kind of disciplined algorithmic way, and we're trying to bring this together in what we do. And before finance, I was an astrophysicist, a PhD in a postdoc in astrophysics.
Thank you. I'm Simon Draper. I run a small business called Copalia. We do use machine learning and simulation and good old-fashioned classical statistical modeling to solve problems for businesses. Going about 5 years, we've got some good clients. We've got Google at the moment, ITV, had Sainsbury's and The Body Shop, and lots of smaller sort of fun clients as well. And we both do the projects, and we also do a lot of mentoring and training within businesses in an attempt to sort of close the kind of gap that we've been talking about today between managers and PhD grads. And before that, I started off about 15 years ago as a statistician. I was really lucky, I guess, because about 9 out of 10 of my class did a topic called financial engineering, and I did computational statistics, which was machine learning, and it was me and about 2 other people. And of course, the financial engineers graduated, I shouldn't even laugh, it's pretty horrible, but into 2008 financial crash. So I kind of flunked that. And then after that, I basically, I worked for a lot of different media companies. I worked for News UK, I've worked for Channel 4, and some media agencies, and the odd, I can't remember, lots of businesses over the time. So yeah, that's what I do, and yeah, I'm very happy to be here.
Hi, I'm Adam Davison. I didn't get to pick my own job title, so I'm Head of Insight and Data Science at The Economist, which has got a few too many words in it maybe, but so I manage the team at The Economist that's responsible for using data for internal decision making and also for improving the experience that our customers receive in our digital products. Before working at The Economist, massive physics bias in the panel, because I also did a high energy physics PhD and postdoc. So I was doing a lot of large-scale data analysis, and that was how I sort of naturally fell into data science as a career path.
For those, especially for those who have a data scientist title or in a title, or you kind of apply that label or title to yourself. Did you have any transformational experiences that made you think, oh yeah, I'm a data scientist, it happened? Pierce. Have a slightly microphone problems.
There we go. So I've got the grey hair, so I've been doing this far too long. So I guess when I first started in business, there was really no data science at all, and I was a bit depressed because I liked doing maths and understanding data, and there just didn't seem to be a home for me in business. It was very odd. I sort of gravitated to bits of marketing science and little bits of operational things, and so I guess there was probably an epiphany when I was being a quant, doing proper quant things in a hedge fund, and then there was a realization that and that was very much what I would call data science, really. But then there was a realization that while that was going on, so this was probably early 2000s, there was this sort of movement coming that was joining the dots in business, that was sort of trying to take these different components of analytical and statistical approaches and sort of calling it some unifying theme. And I certainly found that this was very exciting, because suddenly I had potentially a home. I could go and be one of those people in a business, and it sort of, I felt it very positive, because it sort of joined these disparate communities up, and also felt like, I don't think we've got quite yet to a career around data science, but it certainly felt like it's a capability, it's a skill, and it's something that you can now talk about in a slightly broader way than perhaps you could do in the past.
Yeah, I agree. It was definitely when I realized that I had transferable skills, having been in astrophysics for a bit and then being a quant, and then I was back looking for a kind of a third go, and then I realized that these skills are very transferable, and it was all about helping people make better decisions with data, and that was when people were starting to talk about data science. And initially, when people were advertising data scientist things, I didn't think I was a data scientist, and then as I realized, oh, that's it, that's me, and that's when it all came together. And I think it was, it's fairly recent, like the last 5 years, I think that's what people have been calling it.
Adam, you mentioned something before that you were kind of, more apply the label rather than proactively chosen. Do you identify?
At the risk of sounding ageist, I think I joined the industry a little bit later than some of the other people in the panel, so I think... So very much for me there was a transition from academia to a commercial job where my title was data scientist, so I was kind of thrown in to being one without necessarily knowing what it meant, I think, and so I was doing it by definition, but yeah, I'm probably still only about 80% sure that I'm a data scientist now. I feel like I've done a lot of different stuff, bit of statistics, bit of programming, bit of machine learning here and there, but yeah, I always wonder if other people who are data scientists are doing different things to me. It's still not 100% in my mind, but I guess I am. Yeah.
But that's one of the problems, isn't it? It's this kind of FOMO. We sometimes think that we're not the authentic data scientist, because it does look so different in different places, I think.
Is that one of the consequences of that hype, that we kind of keep hearing that everybody else is doing this great thing and, we just don't do it in my company? Or where does it come from, that fear of missing out?
I think that's very true, because the stuff that gets publicized is, Google's latest. I mean, look at Google Lens. I mean, it's amazing. You can take a picture and it'll tell. Like I took a picture of some flowers, and it told me they were Japanese wisteria. I mean, that's just great. How does that work? I mean, I sort of know roughly how it works, but even so, there is no way there's anyone in my company doing anything like that. And so, not surprisingly, you assume, well, I'm not really a proper data scientist unless I'm doing something like that. But of course, it really is such a broad gamut, and I think there's a real struggle for new or sort of freshly minted coming out of academia first sort of job, because I think you almost have an expectation that's the sort of thing you'll be doing, and if we're brutally honest, it really isn't. I think there's a small piece of any data scientist job that does involve some really cool stuff like machine learning or supervised learning or whatever it might be, but there's a lot which is, I would classify, kind of making better decisions with data, which is much more traditional statistics, much more, frankly, common sense. And I think, I certainly believe that the role of a data scientist is quite broad and involves all of those things.
Magnus, do you think, how does it look like from the academia perspective?
So I think what happened in universities was that when I started doing machine learning and computer science, it was all happening mainly in maths and computer science departments and statistics. And that's where most people were doing machine learning, and they were sort of making new methods and inventing neural networks and so on. And more recently, what's happened is everything's moved towards the data, and people who are doing machine learning and dealing with big data and have big data in things like physics and biology, they're all over the place. So the reason that universities have got data science institutes, or one of the reasons, is that these people can get a bit isolated and kind of, they need a home, and they need a sort of critical mass of people that they can talk to and interact with, go to conferences with, or just go to seminars with. And that was fine when they were all in the same department, but now they're not. They're all over the place, So I think there was a real need to have this new terminology of data science because it's more inclusive. And that's the problem as well, because it's so diverse. Not everyone is an expert in TensorFlow. So not every data scientist they all have the same, their skills all come from the same place, but the skills are quite different. So not all data scientists have the same core skills, I think.
That's an interesting point, because I think this is where we kind of start thinking about this objectification, right? So everybody tells us what we are and who we are and what kind of skills we have and what kind of Venn diagrams we fit into and so on. And frankly, it's quite annoying, right? So what are the consequences of that? What are the effects of that on the business or the markets? Did it help, for example, to grow businesses?
I think sometimes people can get pulled into thinking about kind of methods before they think about what they're trying to do, because there's this kind of idea that a data scientist will be an expert in neural networks or something, and so then a business goes, oh well, I need a data scientist, so I need that, and I'll put it on the job ad. And actually, you should never be thinking about hiring for methods. You should be thinking about what you're trying to solve. And it might be that that's got absolutely nothing to do with the problem you're trying to solve. And so I think it's because of some of the hype, and then because that then leads people to kind of latch onto the bits that sound really cool, and then people think, well, that's the thing that I need, and it all comes then from the wrong way. And so I have I've been in things where people say, oh, I love what you've done, and it works, and it looks great, and it totally solves our problem, but I actually would like it to use more machine learning. And you're like, well, what? Why? It works. So
I can really relate to that. And it links back to the first question. The first job title I had was as a data scientist. Was one where I received a brief from the recruitment consultant, and on the brief it said, we want somebody who's interested in restricted Boltzmann machines. And I thought, wow, those guys really know, they're in deep, they know what they're talking about. It's specifically after a restricted Boltzmann machine expert. And I thought I could probably cover that if I crammed all night. And basically, yeah, they had no idea what a restricted Boltzmann machine was. And you know who I'm talking about, don't you?
Yeah. It was a challenge with people as well.
So I personally think it's a real and it relates to the point about fear of missing out, and I totally agree with the rest of the panelists that particular focus on certain areas is very damaging. And I find that by qualifying as a statistician, I've got a very large tool set of quite diverse but less kind of headline-y techniques, and that they can be used in a really large, much broader set of situations than the headline-grabbing sort of machine learning, deep learning stuff can be. And actually, that gives you a lot more job satisfaction. If you can go to a problem and have an extensive tool set and be able to find something interesting and fascinating, where you can use all your skills in just about any business situation. And I think that for me, that's the bit that has to be cracked by a lot of people who are starting out in this career, is that they sort of come to me and talk about it and say that there aren't any data science problems here. What am I doing here? And I sort of say, well, nobody's going to kind of label them for you and give them to you. What you need to do is take your skills and go looking for them and start thinking about ways in which you can use your maths, basically, to solve problems. They don't know how you're going to use your maths to solve problems. You've got to figure that out. So that for me is, I've babbled on for a bit. But yeah, exactly.
So there is, from that there is some kind of a level of expectations that maybe graduates have, or people who are starting in the field, about like what kind of things they're going to be doing in organizations. How about the expectations of the businesses? Does every business need a data science team? How to manage the expectations of the organizations that wish to be transformed by data by hiring a PhD student?
Well, I mean, I guess I can talk to this a little bit, because I don't think anyone at The Economist will mind if I say that when I joined, The Economist had no data science function on the business side. And I remember being offered the job and wondering the exact same question: does this business need a data science department or not? And I spoke to a lot of senior people who were very convinced that we did need data science expertise, but obviously, as a sciencey person, I was thinking about all the risks.
Why do you think they were convinced? Why senior people are convinced that they need a data science team?
I think a mixture of, to some extent, there was definitely a factor of hype, that they felt that other businesses were doing data science. I think certain businesses in publishing have made a really big deal of their data efforts, the FT, Guardian, New York Times, people like that. So I think that's definitely part of that. I think also there were some people who could see the opportunity as well. So that it would be unfair to say it was exclusively. Right. It's definitely, there was genuine opportunity. In the end, I convinced myself that it did, but and I think we have found opportunities. So I'm not sure that every business does, but I think a lot of businesses, there are problems to solve. I definitely struggle with that myself.
Yeah, I mean, I think it's that expectation thing from perhaps senior people in businesses. I think can be a real challenge. I think it does come from, we're a public company, and so investors are asking all sorts of things to the CEO and the board, like, what are you doing in AI? That's the standard type of question. And of course, then they feel a need, well, we must be doing something. And so I think there's this sort of, this real drive that, well, I must build a data science team because this is clearly what's going to drive the business forward. And of course, that's a proper recipe for disaster unless you've really figured out some of those questions that you need to answer, because we all know that really you're only going to be successful if you're really trying to answer a specific kind of deliverable, a specific question. And I think there's a flip piece as well about the types of people that typically get hired in those situations. It's, I need a heavy-hitting data scientist with all the right PhD we talked about. And certainly in my experience, the first people you need to hire are actually the plumbers, the data engineers, to move the data around, to build the platform so that actually, someone talented can do their job. Because, there's so many instances of people coming in, not really being able to do anything, not really having any specific guidance, and then, frankly, building a prototype and leaving. And I think that's where some of the negative stuff is coming quite at the moment.
Right. Simon, did you want
Oh, I just have to confess, I don't do any data science on my own business. Just, I should analyze the hours and work out how to optimally spend them and all the rest of it, but I can't be bothered. There's definitely more productive ways to spend your time. And I think I'm joking, but it's true. I can see there's no application, and that's possibly because I do it for other people, so I know when not to bother.
Piers, you kind of picked up on the kind of the readiness of the business to really welcome data scientists, or and is that the case? Is there an element of the technologies or the preparation of the organizations are not yet at the stage where they actually can, apply some of the solutions that?
Well, I mean, I definitely think that is the case. There's a great quote from Hilary Mason, who's the sort of chief scientist at Bitly and now at Cloudera, and she always talks about how you can't do AI or can't do machine learning without analytics. You can't do analytics without a decent analytical platform, without the base of what you need. And so few companies, if I'm honest, actually have that. It's amazing. We're not airing laundry, but we're a fully digital company. But it's taken us a while to properly even just get that all the data in the right place and the tools to actually access it without requiring umpteen requests from IT and all this sort of stuff. It is how you build those processes that allow people to be productive and self-sufficient. And I think the flip side of that as well is then how you get stuff live, because I think depending on the type of problem you're working on, but if you really are working on production systems, as in trying to get stuff in front of on a website, you've got to speak the same language as tech. You've got to be able to show that you're doing things in the right way. You've got to code in the right way, and so making sure that you've got all that squared away as well is also critical. And lining all those things up is well, in my experience, quite rare. So there's definitely a lot that needs to get done.
Yeah, I've definitely seen some large organizations really struggle with, the idea that maybe someone who isn't in IT could have a Jupyter notebook, for example, and you get more and more people these days who are learning how to code and they want to start playing with the data, but you can have businesses, and it's just like set in stone that any flexible tool cannot be something that a IT person uses, for example, and so it's just crazy how that company needs to evolve. They need to burn down their whole kind of rule book for how they deploy things, and that's really hard for big organizations to change.
Magnus, do you think that academia prepares?
I was just thinking that anyone who can use Oracle for ordering things can probably use a Jupyter notebook, because that's got to be the hardest tool.
Right.
Sorry.
I was going to ask about do you think that academia can prepare people better for that kind of a first shock of the state of technology in the organization?
Yeah. So I've had students, PhD students, and postdocs go to jobs as a data scientist and turn up, and there is no data science job. And I think it's for the reasons you mentioned, that it's actually quite hard to get all the ducks in a row before you start doing machine learning on data and doing statistics on the data. You have to link together different data, you have to find out where it is, you have to, so there's a lot of getting data ready, and probably a lot of companies think they're ready for data science and probably aren't ready for it yet. And so I suppose PhD students and postdocs probably often don't know what are the right questions to ask when they go for a job interview. They're probably quite desperate to get on the job ladder as it is, and they don't realize that you can have a bad job. But usually after 6 months, they've realized that. And so on the other hand, producing the right kind of people for this, I suppose it's producing people who are more interested in problem solving than method development, and I think that's probably why it's actually good that our data scientists are coming out of biology and chemistry and physics, and not just out of computer science departments, because although I love computer scientists love to code stuff up all the time, and most of you guys probably don't need people to come into your teams and start coding things up. You need people to come in and solve problems. So I think students have to understand that in the end they're solving problems.
Exactly. Just about to say exactly that. I think if we could solve this by just explaining to people that what they're going to be doing is solving problems in businesses with maths. I know I don't want to get into the whole definitional thing, but I think if you tell them that, and that's their expectation, I think they'll be happy, and I think the businesses would be happy. It's the, what's the word? It's the specificness of it that is an issue, isn't it? When they think, as you said before, that they're going to be using convolutional neural nets, that they're not going to be doing that. There's no way.
If you do want to come and do that with me.
Well, I can actually say that it's interesting to hear you guys talk, because I came from a physics background where I wasn't really doing a lot of machine learning. I was doing data analysis on large data sets. And I remember interviewing for data science jobs and thinking, my machine learning knowledge is really, really not up to these. I'm going to have to really sort of like revise in my spare time to get into them. And yeah, now here we are full circle saying that the most important thing is to be able to solve real problems. So yeah, I definitely relate to that.
I think the problem's going to be when the data scientists try and get a job at CERN or something like that.
How about though, because yes, not everything is possible, especially on day one in the organization that just started with building that capacity or capability. But what does it help to the data? What help understanding of the convolutional neural networks? What does it do to the data scientists? Like how helpful that is in their day-to-day job? Is it at all helpful to really understand deeply the science behind this?
I have got a strong belief that so when I'm thinking about the types of people I want in my team, a deep, obviously, passion for this stuff. Like I love it, I really do, and I still talk about, it's terrible. They keep me out of the room, but I'm trying to tweak random forests, and they just go away. It's all right. But fundamentally, you've got to love this stuff and love problem solving. But I think what you do need to understand how they work. So you can't. So I think there's a struggle sometimes with some computer scientists coming into. Who are very good coders, who are coming into, they can leverage some great libraries and build something that works, follow a tutorial, and look, you've built a model. And I think the struggle sometimes with that, and there's a place for it, but the struggle is you don't quite know when you should be using it and when not. And so there are absolutely fundamentals about, you don't need to be able to code it from scratch. You don't need to know the nuances of every sort of, every proof. I read papers, I'm like, I'll take that for granted, that proof, that's okay. But you do need to understand what the underlying sort of, I guess, issues are, the underlying assumptions, so that you can apply the right technique in for the right problem.
So yeah, I feel quite passionately about it, so I just want to jump in. Yeah, you don't really need to understand a convolutional neural net. What you need is a strong background in probability and to understand what algorithms are. And so you need the fundamentals, and then you can probably spend an evening working out how a convolutional neural net works if you have enough, well, that might be a little bit of an exaggeration, but that's way, way more important that you have strong grounding in the fundamentals of all these subjects than a specific one for a specific algorithm.
Yeah, no, I was just going to say, I think, understanding them so you don't think they're magic, you don't think it's just stuff in, stuff out, just so you know when you need to apply them. And also, I mean, the thing is, the difference between statistics and obviously doing something in a business or doing anything in the real world is that it's not perfect. There's no one thing that then works perfectly for your problem. And so you have to understand all the assumptions and all the caveats, and, there's usually a method, and it is the right method to use in a certain situation, but there is never a perfect one, so you've just got to be able to understand enough so you can know what you should be looking at and what are maybe the gotchas.
Do you think that drives a bit of that kind of like lack of understanding what kind of a method solves specific problems and whether it can solve those problems at all is driving some of the over-promising in the organizations? And that comes back to the example that Martin gave at the beginning. If the managers are not fully qualified and understand what are the possibilities, we tend to overpromise. Is that the case?
I mean, it's not an example from business, but one problem in science is that the concept of big data is often misunderstood by scientists. So they'll turn up at your door and they'll say, I've got some really big data. And they'll think it's big data because it's a lot of genomes, and each genome is big, but it will be from 5 people or something, you know. So the sort of it's important for people to understand the basics, like, you know, typically the size of data sets for which you can use certain kinds of methods, and what kind of richness of features you can, you know, that, you know, they'll be reading something about AlphaGo, which is trained on hundreds of millions of games with itself, you know, and has vast data. And then they'll think, oh, I can apply this to these 500 data points that I've got in this data set. And so that kind of misunderstanding of the complexity of method to the volume of data you've got is quite common, I think.
I think the signal, I always think one of the most important things to understand is the signal to noise of the problem you're looking at. There's a lot of these things that, you know, work on, you know, classifying image of cats. I always think, well, every single pixel is a piece of information. Even doing, you know, like language processing, every single word in a sentence is usually useful. But then you get other problems, particularly in finance, where most of it's noise, and you absolutely cannot throw a method that works on a really kind of high signal to noise problem on a low signal to noise one. I think people talk about the scale of the data, but it's not the number of terabytes, is it? It's the signal to noise that you've got in your problem that really dictates a lot of the method you should be using.
But I guess, yeah, just circling back to, I do think that it always comes back to have we got the right manager, the right senior people asking the right questions? And I think often not, because again, in my experience, what happens is we should be doing AI. What are we doing in AI? Why can't we put AI on this problem here, you know, and come on, just go fix it? And I find quite a lot of my job, again, fortunately sitting at quite a senior table, is that education. And what's interesting is it's not just one way of, no, we can't do that, and no, we can't do that, and no, that's not, you're not thinking about that right. There's actually the other way, where you have these, well, I wish we could do this, but I know that's impossible. And I'm like, no, that's quite straightforward. We could do that one. And so you sort of, there's opportunities in both directions. There's definitely a piece of just sort of trying to, you know, calm expectations a bit, or really formulate what the problem is. But sometimes there are these opportunities of like, well, actually, you know, that'll be a great project. Really? Oh, okay, brilliant. We'll do that.
So do you sometimes want to just slap an AI label on it? I mean, that's the other thing.
Oh, all the time. Yeah, it's like, well, we'll call it AI. You'll be fine.
I've definitely been doing deep regression. That's my new label, deep regression. Yeah.
That sounds more psychology. When did you first become a data scientist? It's interesting, the AI thing, because I've been old enough to realize when it became really uncool, and then it sort of came back again. And
it was never uncool, by the way.
The problem is, the Turing Institute, I'm involved with the Turing Institute. The Turing Institute had to rebrand to be the Institute of Data Science and AI. The reason for that was someone from the government came and said, oh, well, there's this thing called AI, and we really need an institute in AI. And the Turing Institute said, you really don't. We are already that, and we are going to add AI to our tagline. And the same thing happened in Manchester. I went to the annual review of our institute, and the higher-up said, well, what about AI? You know, and I said, well, it's the Data Science Institute. We deal with AI as well. And they said, well, you've got to have it in your name. And the thing is, if you don't do it, someone else in the organization will do it, will take over that. So you actually are forced, because this AI term has come in, you are actually forced to adopt it, because if you don't adopt it, you'll end up with an AI team in your company, and the university will have an Institute of AI, and there'll be a National Institute of AI. So
I have to say, there was nothing more terrifying than Theresa May's idea that our post-Brexit economy was going to be saved by our AI investment. Sorry to bring in Brexit.
You think she's AI?
I mean, I think
Any
maybe.
comments on that?
Yes. Oh. I don't even know where to begin. I mean, I was just going to say, I think maybe we're facing something that other technical fields have kind of battled through over the last 20 years. I mean, there's sort of this trope of the software development team where the manager says you have to build the website, the app has to be done in 3 months. And they say, well, no, it should be the other way around, right? We have to estimate how much work this is. We have to figure out if it's even possible, what the but no, it's coming from the top down. And there's obviously been this education piece over the years that senior managers got used to the idea that software development doesn't work that way. And I guess maybe we're now in this phase in data science, right, where over time they will be educated by people like Piers sitting at these tables, and hopefully in some amount of time we'll find ourselves in easier territory.
So, kind of there is clearly a gap between the kind of over-promising. There is the initial expectations of the business for massive value. There's some over-promising. And then there is reality and delivery. What would be your advice for people who are starting to build their teams and want to prove the value, build up on this, and move on and grow teams within the organizations that are functional?
So I can say, as someone that came into The Economist, a non-tech organization, the most important thing was to find something that you can practically deliver to someone who is in a position to take advantage of it. I've definitely made lots of mistakes in taking on projects that seemed like really good ideas, but didn't meet one of those criteria. I think that's the key. If I start again, I would say find something that satisfies those two things, and don't even start working on it until you're really sure that it does.
I guess I was going to say managing stakeholders, which is kind of similar, but like you've got to plan a project with the person who wants the outcome, and then keep them a bit like your point about software developing. I don't. Going away and saying, we're going to solve everything, and you're not engaging with the stakeholders, going to lead to a little bit of, they're going to want to see results. So you've got to kind of manage that journey, manage their expectations. I think that's the advice. And just really, really work out where's the value going to be, and work that out with them. I think one of the really important things about effective data science is the domain knowledge. There isn't anyone who can go in and solve those businesses' problems until they've understood the business. And so if you really are starting up a team, I'd actually just say you've got to spend a few months just really understanding the business and going through the process and thinking, well, if you had that data there, would it make a difference? Because there's lots of kind of people who would say, oh, do this for me. Then you're like, if I did, would it actually do anything? And so working out where the value added is going to be, and doing that with the business and engaging with them so you get the buy-in, and then just say, right, we've done this massive kind of audit of your needs. I'm going to hit this and then hit this and hit this and find the low-hanging fruit and get going like that, but really engaging on where the impact's going to be.
Yeah, just to add, I think certainly the upfront bit we've talked about, which is what's the question. Sometimes we go as far as designing what the output's going to look like, and then going through the process of, okay, if it looks like this, what are you going to do? Like, what are the actual decisions you're going to make on the output? And so actually, when you then deliver, something happens, because I think sometimes we've all been there. You do a bunch of work and you go to present it, and everyone sort of nods and shrugs and you move on. But so actually making sure that there's some actions that can come out of what you're going to do, I think is really useful. The other thing, if you're fortunate enough to have a sort of, or be able to look at different aspects of the business, we were talking about this earlier, I think people often gravitate to the sort of glamorous external customer-facing stuff. But I think there's, in most companies, quite a lot of opportunities for internal, what frankly used to be called, and probably still should be called, operational research or operations optimization, where you're really just improving processes and automating things, but just making it easier. And I think sometimes there's some quite quick wins in doing that because people aren't aware of what's possible.
What are the kind of elements or components that need to be in place in the organization to kind of get going? So, Piers, you mentioned at the beginning the makeup of the team. So you have kind of from engineers to data scientists. How does it help you?
Yeah, I mean, I think depending on if you're coming into an organization, as we talked about, and you're trying to assess whether this is a good place, to work, whether you're going to be able to do data science. I do believe, as I said earlier, understanding, does this organization have any data engineers? Do they have any sort of centralization of the data, and understanding where it all sits is really important, because otherwise you just can't do your job. And then I think, again, I have this mix of what I guess we call product analysts, who are doing more sort of reporting-based stuff, and data scientists, and I think there's always a good question around what is the mix of the work. I mean, am I going to be building models all the time, or is the expectation I'm going to be writing some SQL code and building a report and really teasing out the sort of the type of work that actually is required is, I think, really important.
I mean, I think personally the most important thing is to have a problem to begin with. I mean, then you don't have the case of the wandering data science team in search of a promised land. You know, that to me. Sometimes people argue that you need a data science team to work out what the problem is. But I think, in my experience, the companies for which it's worked best with have reached a level of maturity with their own problem-solving skills that they realize they can't crack this. And they knew it's a quantitative problem, and they've seen around that similar things could help. But they definitely have a problem to be focused on, and that, for me, is the most important piece.
Do you see any difference as well in the kind of internal organization or within a company data science as a function, as a support function, versus having a product and selling the product, data science product to other organizations? And how do you sell the product? How do you sell the data science product really to other organizations?
I mean, I think where the data science is really, really driving the product, those companies are usually they're usually more mature. They've usually got technical. If it's a company whose product is a technical thing, then I guess that I'd expect there to be less problems in those in terms of them being technical managers usually. So I think my experience, well, actually, I'm not very experienced in this, but usually my understanding of not having technical people in the C-suite or whatever is where you've got a business which isn't particularly data-driven, and they're just setting out in the first place. But that's not to say there aren't challenges. I think in the ones where, so particularly in finance, it's obviously all driven by data, and so in some ways the whole thing is a big data science machine. But I think what happens there is you want to talk up your product, and to do that you talk up the data science, and so you sometimes end up feeling that the data science is being used a lot as a marketing ploy. And so half the energy of the data science department can be to do things that kind of look clever and look sexy and not necessarily actually deliver output. So I think that's the risk that happens where the data science is part of the product, and it's probably less of a risk where the data science is more just operational. But there I imagine the challenges are actually you haven't got very technical people in the organisation.
Yeah, I mean, I guess I joke with Martin about this. He's got a fantastic company doing some cutting-edge AI, and yeah, beer later. But it's incredibly hard to sell that into a company because I think typically, sadly, and maybe it's changing, but the data science piece of the organisation doesn't really have a budget or might have a little bit of money but they're not the ones who are in many places making that decision. So poor Martin's got to go and sell to the CFO or to a head of marketing who really don't understand what he's talking about. and it's really hard then to get across the benefits because you're not dumbing it down. And I guess it's really it's obviously really good to be able to articulate what the value and the benefits are. But really, you want to be talking to the end users and the people who understand what's going on. And it's quite hard to navigate that, I think. So for a B2B company doing data science, I think the good news is if you're working in that company, hopefully you're doing some pretty cutting-edge cool stuff with like-minded souls. That's brilliant. I guess the downside is figuring out where the money's coming from to actually continue doing that is much harder, I think.
I think actually budget is a very interesting topic in itself, because I think, Magnus, you mentioned, for example, the Turing Institute and or kind of other places when you stick a AI at the end of your company name or organization name, there is suddenly quite a lot of capital available. To do it internally in the company to actually gain budget, I found it quite challenging. Why do we have such a big differentiation? Why do you think that it's easy to go outside and get a lot of capital to do AI-like things versus to build a business case internally in some organizations? And maybe that's not everywhere the case, but to build a case internally, it's really, really challenging.
I mean, certainly, I do think it's quite hard to to articulate the sort of the pounds and pence that a team has generated or driven. I think going back to what Simon said, having a very specific problem that you can attack, I think is brilliant. But once you've got a team and once you're up and running and saying, well, look at the payroll cost on that thing, have we really sort of kind of got a return on that? You know, it can be hard to justify. And I think often, so we had an interesting example with sort of our product analytics, you know, so we do A/B testing, and historically that was done within the product team, not very well, and so we decided to sort of industrialize it, you know, a bit, do it properly, took it into the sort of data science team, and properly, you know, really as rigorously could build a process. And I think what was nice was we were able to show over the course of the year, and it's a combined effort. Obviously, the product team are coming up with ideas, but we're measuring it. We were able to show, you know, proper increase, you know, of 5 percentage points of conversion rate over the course of the year. Again, a combined effort. It tends to be a shared thing, but we definitely contributed to that. And so I think it almost has to become this holistic sort of overall picture of what you're trying to do with the business, and that really comes again back to aligning to sort of key metrics that you're trying to improve.
So I was going to ask one last question to kind of, you know, maybe a suggestion to all the businesses. So do you think that all CEOs should be replaced by chief data scientists? Yes?
I don't know.
Sorry.
Sorry. I think a CEO sometimes has to wing it without any data, and I think a chief data scientist would struggle to do that.
No.
I've seen firsthand what our CEO does, and I definitely want nothing to do with that. So,
Yeah, I was going to say exactly the same thing. I think it requires some skills that a lot of data scientists don't have.
Yeah. We're not very good at golf, that's for a start.
So we're going to hand over now to the audience. We're going to probably, Martin, you're going to do the mics. One of the mics that we can do. Yeah, does anybody have any questions? Yeah.
Hello. That was fantastic. Thank you very much. Really enjoyed that. I have a question that comes back to something that you mentioned, Piers, which was on the point of productionization. And I'm just curious as to what you think. And we also run a course at our company, and this comes up a lot with the data scientists that we train, which is that to what extent should they be responsible for the productionization of their models?
I mean, again, contentious. So definitely I've been in places where a data science team will create a model, and then the only way it goes live is a tech team, you know, rewrites it in Java, and of course, how you then update that model or improve it is incredibly painful. So personally, I believe, yes, a data science team, or at least components of a data science team, should be able to, A, get things live, and be on the hook, frankly, for making sure that it works. Because I think that's the only way you get the iteration and the ability to improve, which is really what it's all about. It's not about a one-time thing. Now, of course, that's a different skill set. And so I think that's the blend that becomes difficult, is you definitely need more software engineering skills, or at least within the team associated with the data science team, in order to do that. And it does take also, you know, if I'm honest, a bit of a leap of faith from the tech team to sort of hand over the reins a bit, to say, okay, well, you know, as long as you're careful. But I guess what we're finding is that the service, that some of the cloud services, particularly on Google, just make a lot of this stuff much easier, and just require that less tech interaction. And so I think that direction of travel does make it more viable and more possible.
Just from a career perspective, is there anything that a data scientist can do, say, adding to their CV or something like that, that can show that they have those kinds of skills, or they understand them?
I can just carry on. So if you've gone and got, for instance, GCP, you know, software engineering, or sort of some sort of Coursera certification or AWS certification around kind of building an API or things like that, again, it's tangential to data science, but it certainly would add to your worth within, like, my team, for instance.
Thank you.
Any other questions? Yes, over there.
Hi, thanks. Kind of following on from the careers discussion, really, I think you've all touched on the fact that sort of the title data scientist covers a really broad range of skills. And one thing I've noticed recently, kind of looking at the sort of trends and what people are advertising for, there seem to be quite specific roles coming out of the sort of data science area. So things like research data scientist versus product data scientist. So I guess those are the people that are putting code in production, right? And then you have like machine learning scientists, and then data science engineer. And do you think there's a trend where, like, because it's got so confusing, it's now gonna split up into multiple careers? And do you have any comment on which ones you're seeing as being like some of the best opportunities for people progressing in their careers?
So I grabbed the microphone because I have a strong opinion on this that I know Martin disagrees with, which is that I believe that data science is kind of in the process of slightly dividing into two separate areas. One which I think is essentially machine learning engineering, which is people who are mostly building models for production machine learning tasks, automated decision making, and another which is more close to the kind of the operations research idea. I'm not sure what any of them will be called in the future, but that's the sort of the division that I see in terms of opportunities. I mean, I have absolutely no idea what's the right thing to do, sorry.
I would just like to remember my example about the restricted Boltzmann machines. I would be really wary of the way in which those job titles are arrived at. I wouldn't judge it take it too seriously. I'd go for the interview if I were you.
But I think it would be good if we mature into appreciating the different... I think one of the things we struggle with this idea is that every person is going to do everything. So, you know, those Venn diagrams you get that we're all great at statistics and domain and coding. You know, we obviously know that's not really true. The team has to be good at all of that, but not every single person is going to be an expert. So I think it is going to be a healthy thing if we mature a little bit such that those job titles become a bit more specific, but we don't want to lose that sense that we are all in this together and this is a collective problem-solving activity. But yeah, I don't know what it will be called.
Did you just use David Cameron's campaign?
I guess just one quick add-on. Certainly, those sorts of roles, I would argue, only exist in properly, you know, cutting-edge places like the Googles and Facebooks. And I think if it's a company that is offering those sorts of roles and isn't one of those, then you should run very quickly. But you know, in my simplistic view, I tend to characterize it as exactly what Kate was, well, actually we've been saying is, do you like helping people make decisions, or do you like helping machines make decisions? And so they're sort of slightly different skills, and clearly machines is a bit more sort of software engineering-y, and people is a bit more telling the story and designing and visualizing. And I sort of feel similar to what Adam was saying. Those are the sorts of areas it will end up gravitating to.
Yeah, I think that's a nice way of putting it. Thanks.
Thank you. I would like to turn the original question or the problem from the beginning, the non-data scientist managing data scientists, on its head. I was the first data scientist in my company, and that was for a time, and then stuff got crazy, and I'm losing track of who actually works for me. How do you build good data science teams? How do you manage them well? And, well, yeah.
I'm not sure I know about how to build a good data science team, but it's funny, I was talking to a guy called Alex Schultz, I think. You know, he's a VP at Facebook in California. He's a Cambridge grad. And I said, well, what do you do? Oh, you know, I run analytics at Facebook or something like that. And he said, oh, that's quite a big job. And he said, yeah, so how many people are in your organization? And he said, well, about 8,000. I'm like, oh, bloody hell. So I said, well, so this sort of question. So, well, so obviously, you know, you look to hire really, really technical, cutting-edge data scientists, but what about managing all these teams? You know, what sort of skills do you look for? Do you need them to be technical? He says, no, not at all. and I sort of balked at that because I do believe I need to have the credibility to actually understand what people are talking about and sort of push back on methods and things like that. But I guess at that scale, there is such a lot of sort of project management and stakeholder management, and so I can certainly see that those skills that may not come naturally to someone like myself or other data scientists are really important, and so you might need a blend of that. One thing I've sort of thought about is I kind of feel like there's a role for almost a data product managers to help coordinate a lot of stuff that goes on somewhere around the team. But I'm still pretty passionate about needing that technical skill even at a higher level. You just might need some management support.
We just have one mic, so.
Sorry, I didn't have an answer. No, I'm not going black. And no, I genuinely don't. I genuinely don't know how to build a good data science team. I actually don't.
I think there is an element of it depends on the organization as well, because I think from my experience, you have a different makeup of different skill sets, but I think the bigger the organization as well, the more bureaucratic the organization, you need more people who are able to manage stakeholders and go and really make sure that data scientists can do their job, can do data science rather than kind of managing stakeholders and writing emails to HR and stuff. So.
Sorry, just to come back, I think one good question to ask yourself is why, in those places where it's failed, why are people leaving? Because I've seen that happen a lot, and usually it's because there is this terrible mismatch between their expectations and the management's expectations too. So I think it's about compromise on both sides there. And like I said earlier on, it's as much the task of the data scientist to find out how they can help people. So I think instilling these values in your team is probably going to be the thing that makes them stick around and be useful.
Cool.
Am I allowed to answer?
Here in the front, sir?
Am I allowed to answer?
Okay.
Oh, thanks.
If it's a nice answer.
I've got some ideas on how to build a good data science team. I think you definitely need to have people who are going to be coding production code, as Piers said. I think the idea that you need separate teams to do the software engineering and separate people to do the data science is, first of all, it's never going to work because the engineers are going to try to translate the algorithms into something that goes into production. If they don't understand something, engineers don't necessarily ask the data scientists what that line of code meant. They normally just remove that line of code. I've seen it happen loads and loads of times. So that's really, really challenging. So you have to have data scientists who can code, and you need people who are really driven to build stuff. They're driven to make stuff and build something that's actually going to change the business. They're absolutely deadly, I think, for a data science team is to have loads of people who just like coding up algorithms. It's just going to be a disaster, and I've seen that happen loads and loads and loads. So those are two things that I would say. Oh, actually, I'm going to say one third thing. Sorry, which is I don't agree with this thing that you shouldn't be building your own data sets. That you need a data engineering team to like make your data nice. I think science, the history of science is that building your data set is always going to be really challenging, and it's always going to be really painful, and that's what people have done for hundreds of years in science. Anyway, I'll stop talking.
I've got to respond. No, I guess I've got a funny position because I sort of broadly think of it all as data science in some ways. So I'm not making a differentiation between data engineering and data science. It is a continuum, and you just need people who are doing it, ideally co-located, doing it together. That's all. But I agree, any good data scientist should be a very good data engineer as well.
There was a question here in the front first.
So I was wondering if you think there's a place for perhaps a professional body or perhaps the DSS itself to create like a standard or a set of criteria of what a data scientist should be and what they should have and what they should be able to do? Or is data science too fluid and too malleable to kind of fit into like rigid boxes like that?
No, I think there definitely is some core skills. I mean, just going back to your point at the beginning, there's some things where it's laughable if you don't really understand it and you call yourself a data scientist. So yeah, well, it's not got to cover areas of specialism. It should, as I said at the beginning, cover the fundamentals in quite a lot of detail. So yeah, I agree. I think they should.
I'm not so sure. I think we've argued in this panel in the last 45 minutes alone about exactly, what the role means and things like that. I think maybe maybe in the future. I think maybe it's a little premature now. I mean, I can see a place for it, but I'm not sure we're quite there yet.
Just from a sort of education point of view, so there's a lot of master's courses in data science cropping up, and I think it's quite important that people do think about. So it's clearly a very diverse thing, and you can specialize into lots of areas, but I think you probably do need some kind of guidelines over what all those master's courses are going to deliver, because otherwise people are going to turn up and they're just not going to be served a useful product, and people are paying a lot of money to do these master's courses. So for instance, in software engineering, there's an organization that that accredits courses, so they get a stamp of approval because they're teaching what's considered a sufficient curriculum that you could call it a software engineering master's. And I think in data science you could have something similar. So it doesn't have to be so rigid. It means that you have to come up to a certain level in terms of the amount you're teaching, which would be considered core data science as a useful master's. So I think that would probably be useful, and it'd be useful for universities as well, I think.
Like any curriculum, you normally have a core, don't you, and then diverse in the later years. Sorry, I've said that.
Where should ethics sit? Should a data scientist do their own ethics, or should that be a separate role in the organization?
No, 100% they should. I mean, one of the strangest thing about this field is, or one of the most interesting, is the shocking things I've been asked to do. I won't go into them. Ask me over the drink, but it's mind-boggling what good people will, otherwise good people will ask you to do with data. I've intrigued you now. You'll definitely be asking me, won't you? So yeah, you cannot avoid having a conscience with this stuff, I think.
If I can add something as well, I think yes, there is a responsibility in the data scientist, but again, it depends on the organization, where you also have other pockets or other functions that need to worry about their own ethics. So, as an example, at the BBC, yes, as data scientists, we care about public interest, but we also work with editorial guidance and policies and so on. So there are other people who are knowledgeable of the domain that need to input into our kind of knowledge as well. More questions?
I'm interested in sort of the overlap and the interrelationship between sort of data science and behavioral science. So in my former job, I had both a behavioral team and a data science team. And actually, I left the organization just at the point there was really starting to be a lot of interaction. But I think there's a huge potential for it. And my current team is just data engineering and data science, but I'm totally planning to build a psych and behavioral team. And I'm very interested to see what opportunities you guys all see.
I see a huge overlap, particularly in finance. I think actually the job of the data scientist is usually to address behavioural issues and how people are making decisions. And so a lot of the role of a data science initiative is usually to bring rigour to a process where otherwise people have been making decisions and having to and where the people have been making decisions without data, then that's the thing that gets ripe for behavioural issues. And so yeah, I see a huge overlap, definitely, because a lot of it is about decisions, and the decision making is about behavioural issues, I think.
Also, bring back the research teams, the poor old research teams with their surveys. There's so much value. Often, doing a survey is the best way to get an answer to something. So they've been languishing for years while this big bubble has been blowing up. I think they should be integrated, and the way of doing things should be brought back into the fold. So I'm really for that in the sense of, they could be working on the behavioral science type problems.
We have more questions over there, Dan?
Thank you, panel, for your interesting insight into how data science can help the industry. So my question would be, is there any way you see that in different size of companies or corporates, data science can help the companies to earn a competitive edge over the long run, rather than building a software or service that is definitely have to contribute to the sales target this financial year, but over a long period of time? Do you think that long-term thinking is going to help data science to embed into companies in a more sustainable way?
Yeah, I think that's a really good question. I think data science can look different if you're doing it for a short-term win or a long-term win, and actually working that out, if you're going for a job or working out with the business what they're looking for is really important. I think it can deliver both, but they look different, and the long-term one is the one the business should be going for, but that usually might require a little bit. It's usually a different project, I think.
Yeah, and I think startups can get into the sort of mindset of thinking in that way, specifically going back to a thing I've been harking on about, which is the problem solving with maths element of what everybody does. If they can do that right from the beginning and have that built into their way of working, then I think that gives us an enormous advantage. And I see personally among my clients, those who are small to medium size who are already doing that, I think they're in a really good place. I think it's a lot harder if you're huge, and then you tend to go down this let's build a team route. So yeah, I think those ones who are doing that now should be in a good place.
Any more questions? Yep.
We can do it over wine.
One more.
So you have been talking a lot about early career data science, how you start and so on. And it's something that I think every data science tends to focus on. Do I learn this? Do I learn that in methods and so on? But when you're talking about a little bit further in the career, everybody should start focusing on more soft skills. So, how do you approach this within data scientists who we tend to be more focused on the data and not on the people stuff? And in order to get there, to have data science managers and so on, you need to be good at people.
Magda was just telling us earlier, you're doing an MBA. This is what you were thinking. You've been a data scientist for a long time.
That's why I'm nearly falling asleep and really dreaming of wine. I think there is an kind of an element of transition, and I think we need to kind of like keep checking ourselves whether we want to pick a purely technical, a individual contributor career, or do you want to transition into a more kind of a leadership role and take into account all the consequences that are coming with that, because leadership and running big teams and so on is not all fun. Just as well as kind of being on that one kind of a more technical side. So I think it's about kind of checking in. What are the gaps in your portfolio?
I think also practice explaining things. I mean, I think that is a very complementary skill for the kind of area that we work in. I think, personally, for every bit of work that you do, if you can somehow, if you're in a junior role, get on the team who is presenting it, I think that will put you in really good stead. Because I think if there's one thing that you might not want to be a manager or make big sort of important decisions in your later life around business, but if you want to kind of go forward with this, being able to communicate is absolutely essential. So that's what I would practice and develop.
Yeah, I was going to say, I think one of the challenges maybe for people coming from technical backgrounds like us is that, you know, there's no course really that you can go on that's going to solve that for you for soft skills. It's not like, you know, you go and read a book about a programming language or something like that. You have to be presenting, right? It's the only way you're going to get good at presenting is to do it a lot. You know?
We're going to get the last comment in as well.
Okay. I'm going to tell a story which I've actually told on many, many previous occasions. Many years ago, when I was starting out as a very, very junior assistant statistician in the Government Statistical Service, I went on a course which was addressed by the then head of the Government Statistical Service, the late Sir John Boreham, and I can only remember one thing from that entire 2-day course. But Sir John made the comment to all these young, new recruits. He said, "You're statisticians, but never, ever forget that the most important product you will ever produce is the words that describe your work that you've done." And I think that lesson's lived with me all through my career, and I think for data scientists, the same thing is true now. It's not the technical stuff that you've done is of no interest whatsoever to the people sitting around that board table. It really, really isn't. And I think one last comment, I heard a lot on the panel about solving problems, finding problems to solve. Yeah, that's great, it's fantastic, marvelous. But what you really should be asking yourself is, how do I add value to my business? And that's where I'm going to stop.
And I think that is really important. Thank you so much for that. And thank you so much to the panel. It's been amazing and really interesting conversation.